Hello, friends. Welcome to another session. And what we are going to talk about today, we are going to talk about HCF and LCM. But before that, just want to take some time on the problem that we discussed in the last session, and we have thought of making you aware or enable on what to be done on this kind of problem. So close the previous session with the problem that you can see on the screen as a homework, and if some of you have solved the problem, you can continue watching the solution. Or if you are not able to solve, or if you're seeing this video for the first time, so I would highly recommend go through the recording of the previous session, which is our the second session on number system. uh, and that's where you will be able to understand how we are doing the number system problem. So the first two sessions on number system, if you have not gone through, please go through them. I'll put the link in the description box and you should be able to see them. So we did division, we did factorization, and basically the division equation we started with. Before starting today's topic on HCF LCM, I just want to quickly cover this problem and see how many of you were able to solve the problem, and if not, how we should go about solving it. Okay, so let's say, so if you read the problem, it says a number when divided by the divisor leaves a remainder of 5. So leaves a remainder of 5. That means if the number is n when divided by 5, so that means your divisor is 5, leaves a remainder. So let's say q is the quotient, and lead divided by a divisor leaves a remainder of 5. Okay, 5 is the remainder. So let's say divisor is dq plus 5. The same number when divided by 3 times of the divisor, so d becomes 3d. So n, the same number 3d, obviously it will have a different quotient, because the number divided by d, the quotient will not be same when the number is divided by 3d. Let's say this is q1 and the number is 25. Okay, so these are the two remainders. Now, with these two, let's see, can we identify what will be the number? What are the possibility? How many values the divisor can take, not the number. They ask how many values the divisor can take. So D is what? That's what they are asking for. So let's go to the next page. So we know both are equal to the number. So 3dq1 plus 25. So I'm equating these two equation. Now take D on completely on the one side. So that becomes q minus 3q1 is equal to 25 minus 5. So D into q minus 3q1 is equal to 20. So if you get this equation, so here how we can write 20 as a product of two numbers. I can write 20 as a product of two numbers. So 1, 2, so D and Q into 3Q minus 1. So these are the two numbers I have. A multiplication of that gives me 20. So I can write this as 1 into 20, or I can write 2 into 10. 3 is not possible. So 4 into 5. Similarly, 5 into 4, 10 into 2, 20 into 1. So these are the only ways I can write. But if you see, they say so from here, can you identify what are the feasible values of D? So not all of these are feasible. This is an indication. Why not all of these are feasible? Because when you are dividing a number with D, it is giving a remainder of 5. So D itself should be more than 5. For example, let's say you divide 10 by 3. What is the remainder you get? The remainder is equal to 1. So any number, if you divide by 3, you will never get a remainder which is more than 3. For example, any number, if you divide by 5, you will never get a remainder which is more than 5. So if that part is typically clear, so you know what we know, your remainder will always be less than the divisor. your remainder will always be less than the divisor. So in this case, only 10 and 20 will satisfy, because when divide by d, you get a remainder of 10, a remainder of 5. So your divisor will always be more than the 5. So these are the two values that d can take, 10 and 20. Okay, so this is a quick problem we just thought of covering up before going to today's discussion. Okay, now if we move on. So today what we are going to talk about, we are going to talk about HCF and LCM. Any difficulty, if you have understanding on the previous problem, please feel free to reach out and drop me a comment in the description box, or you can mail me in the mail ID given below. We'll be able to guide you further. So these are HCF and LCM. Now, what is HCF? HCF is highest common factor. So for example, if I have, let's say, two numbers, let's say 4 and 6. 4 has the factors of 1, 2, and 4. 6 has the factors of 1, 2, 3, and 6. These are the four factors of 6, and the other one is the three factors of 4. Now, if I do compare these two, I can see 2 is the highest factor, common factor between both of them. 3 is not in 4, 6 is not in 4. Similarly, 4 is not in 6. 4 is not a factor of 6. 3 and 6 is not a factor of 4. So 2 is the only common factor. So we can say HCF is equal to 2. So 4 and 6 has a HCF of 2, right? This is what we mean by the highest common factor. It can be with more than 2 number. So let's say you have 8, 10, and 12. 8 typically has a factor of, let's say, 1, 2, 4, 8. 10 has a factor of 1, 2, 5, 10. 12 has a factor of 1, 2, 3, 4, 6, 12. Again, I can see 2 is the highest factor that is common in all of them. There is no other factor that is common in all of them. Okay, so that's how, this is what we mean by the highest common factor. So here also my HCF is equal to 2. Similarly, what is LCM? LCM is least common multiple. HCF is least common multiple. So basically, let's say the 4 and 6. So which multiple of 4 is the same and common with 12? So 4, what are the multiple of 4? 4, 8, 12, 16, and so on. And what are the multiple of 6? 6, 12, 18, and so on. So I can see that 12 is the least common multiple between 4 and 6. So LCM is 12 of 4 and 6. Okay. So what we understood, HCF of 4 and 6 is 2. LCM of 4 and 6 is 12, right? So this is what we got. Similarly, if I get 8, 10, 12, what are the LCM? 8 has typically 8, 16, 24, 30, and goes on. 10 will have 10, 20, 30, 40, and so on. Okay, this is 32. Okay, 12 will have 12, 24, 36, 48, and so on. So if you see, 120 is typically the number where it will have all of them have a multiple or as a multiple. So 120 is the LCM. So if you go on, you will see LCM is 120. Now, how we calculate HCF LCM, I'll come to that. But this is what we did. Okay. So for 8 HCF of 8, 10, 12, we got us 2. LCM of 8, 10, 12, we got us 120. Okay. So these are the two things that you need to understand at the very basic of HCF and LCM. Now, there are multiple ways to calculate HCF LCM. So if we see HCF of 4 and 6, if we say there are a division method. So you divide by 2, you'll get 2 and 3. Similarly, with 8, 10, 12, you divide by 2, you get, because 2 is the common factor on both of them, 4, 5, 6. Now you can see there is no other common factor. If I take 4, 5, and 6, there is no common factor between them. So this part is your HCF. Okay. Here also between 2 and 3, there is no common factor. There is nothing going between these two. So 2 is the HCF here. So that's how you calculate the value on the left side of the division method is only your HCF. So let's say I have 24, 48, and 72. Okay. So I divide by 2 first, 12, 24, 36. Again, I divide by 2, I'll get 6, 12, and 18. Again, if I divide all the numbers by 2, I'll get 3, 4, and 9. Okay. 3, 4, and 9. Let me see if I did right. Yeah. So 24, 48, 72. Now you tell me what is the HCF? What is the HCF of 12, 20, 24, 48, and 72? Okay. Okay. So, okay, there's one mistake. This is 3. This will be 6. 3, 6, and 9. Now, again, for the 3 will go. So 1, 2, 3. Now there is no common factor between these 3. So HCF will be taking these numbers only. So taking these numbers, we can say 2 into 2 into 2 into 3. It is 24 is the HCF of 24, 48, and 72. So that's how this is one method of calculating HCF. The similar way, the other way of calculating HCF, I'll come to that. But first, let's see how you calculate LCM in this method. So if you have 4 and 6, you start with 2, you get 2 and 3. So there is no other common factor. Your LCM is typically take everything. So 2 into 2 into 3. So 12 is the LCM. Yeah. Similarly, you take 8, 10, and 12, right? So you got 2, 4, 5, 6. Now for LCM, only difference between HCF and LCM, you should stop division as soon as there is no other common factor between all the values that came out of the previous division. And so in this case, 2 and 3, there was no common factor, I stopped. In this case, 1, 2, and 3, no common factor, I stopped. In this case, 4, 5, and 6, there is no common factor between all the 3. All the 3 is very important, or all the output of the previous division is very important. For LCM, it's not mandatory to have a common factor between all of the outcomes. Even for any more 2 outcome, at least for 2 outcome, if there is a common factor. So here 4, 5, and 6, there is no common factor between 4, 5, and 6. But between 4 and 6, 2 is a common factor. So between any of the 2 outcomes, if you have a common factor, you should keep doing it for LCM and not for HCF. So if you divide by 2, you get 2, 5, and 3. 5 will remain as 5. Other 2 will remain. Now 2, 3, and 5, typically now there is no common factor between any of the 2. 2 and 3, there is no common factor. 3 and 5, there is no common factor. 2 and 5 is also, there is no common factor. So between 2, 5, 3, 5, or 2, 3, there is no common factor even between any of the 2. So that's where you should stop. So now your LCM with 2 into 2 into 2 into 5 into 3. We'll get 120. So that's how you calculate LCM. So the difference between HCF and LCM calculation by division method is this, where you stop the division when there is no common factor between in all the outcomes. You keep doing the division even if there is a common factor between any two values of the outcome. By outcome, I mean these stages, each of these stages, this stage. Okay. And for HCF, you just take the leftmost values, the factors on the left, and multiply them. For LCM, you take the entire thing. What are the factors on the left and what is finally left with. So here the factors were left on 2 and 2, and then we take all these 2, 5, and 3 and multiply. So this is the way to calculate HCF and LCM. Now, there is also another way of doing HCF and LCM that's called the factorization way. So for 4 and 6, so 4 is what is 2 into 2, or we can say 2 square. 6 is equal to 2 into 3. Now, by seeing this only, I can say your highest common factor between this is only this 2, 1, 2, because there are 2 2s in 4 and there are 1 2 in 6. So HCF, which is common in both the cases, is only 1 2. That's 2 to the power 1 or 2. Now, when it comes to LCM, it will be the highest power of the common factor. So highest power of the common factor here is 2 square into 3. So your 4 into 3, 12. So you take everything, and whichever is the common factor, you take the highest value of that. So for LCM, take every factor and highest power of common factor. And for HCF, take only lowest power of common factor. So this is your HCF and this is your LCM. Take only lowest power of common factor for HCF. Take every factor and highest power of the common factor in LCM. Now, if you see typically, you have 8, 10, and 12, right? So for 8, I can write it as 2 cube. For 10, I can write it as 2 into 5. For 12, I can write it as 2 square into 3, right? Now, your HCF, what it says, take only lowest power of common factor. What is the common factor between all these three? 2. What is the lowest power of 2 in all of these 3? This is here, that is 2 to the power 1. So we will have 2. LCM, what it says, take every factor. What are the defined factors? Defined factors are 2, 3, and 5. And highest power of the common factor. What is the highest power of the common factor? The common factor is 2. And what is the highest power of that? That is 3. So I will do 8 into 3 into 5, or 120. So this is another way of doing it. So there is one way of division way, the other one is the factorization way. So both the ways you can do HCF and LCM, and you should get the same value. Okay. Now, this is the way of calculating HCF and LCM. The next part is basically coprime and properties. Now, first understand what are the coprime numbers. We did touch upon this concept in the previous session, but I'm repeating again. So coprime, when two numbers have HCF equal to 1, or in other way, there is no common factor between two numbers. So like I said, 2 and 3 are coprime, and understand coprime is only possible between two numbers, not more than two numbers. So 2 and 3 are coprime. 2 and 12 not coprime because the HCF is not 1. But if I say 2 and 9, they are coprime. So what you can understand is individually they may not be prime, and this is very important. 9 is not a prime number. Or if I take 4 and 9, They are also co-prime. 4 is not a prime number, 9 is not a prime number, but their HCF is 1 because there is no common factor between 4 and 9 apart from 1. So that's why 4 and 9 are co-prime. Okay. Now, if you see what is 8, the same example of 8, 10, 12. Okay. Or let's say, just take two numbers. Let's take 8 and 10. So 8 is 2 cube, or let's take 10 and 12. It will be easy for you to understand. 10 is 2 into 5, and 12 is 2 square into 3. Okay. So if these are the two numbers, we can say the numbers which are not common, they are co-prime. So these are your co-prime. First you have the common factor, and then you have a co-prime number. Okay. So from here, what we can say is, let's say a number n1 written as a factor is common into a co-prime number. So let's say n1 and n2, your h is the HCF, and n2 is, I can write as h into k2. So for example, take an easy example of 4. 4 is 2 into 2. 6 is 2 into 3. So these two is this is my HCF. So I can write as 4 into my HCF, or which I can note as H. 4 equal to H into K1, and 6 equal to H into K2. Whereas I can say K1, K2 are co-prime. K1, K2 are my co-prime numbers. And which are this 2 and 3. 2 and 3 in itself are co-prime numbers. Okay. Now what I'm trying to say is there are two ways. So if I write n1 equal to h into k1, n2 equal to h into k2, to do this approach, we will see n1 into n2 equal to h into h into k1 into k2. Okay, h into h into k1 into k2. So this is the product. This is your HCF, and this whole part is your LCM. Take an example of 4 and 6. So 2 is 4 into 6 is equal to 2, which is my HCF, into HCF again, that is 2 into the other 2, this 2 and this 3, 2 into 2 into 3. So 4 and 6, your HCF is there, and then the LCM part. So this part is your LCM. So 2 into 2 into 3 is my LCM, where 2 is the HCF and 2 and 3 are my LCM. Okay. So this whole part is my LCM, or which is 12, right? So 4 and 6, I know HCF is 2, LCM is 12. So 4 into 6 is 24, 12 into 2 is 24. So what we can say, product of two numbers equal to HCF into LCM. A very, very important topic here. Please pay attention. And this is only valid for two numbers. So product of two numbers is equal to HCF into LCM. So if you see carefully, product of two numbers is equal to HCF and LCM. So if I have N1 into N2 is equal to H into H K1 K2, where this is your HCF and this is your LCM. So what we can say, number 2 is LCM and N1, N2 are multiples of HCF. So LCM of our two numbers and the numbers itself are multiple of your HCF. Or HCF is the factor of both the numbers and the LCM. Now, number 3 is basically what you understand is if HCF of A and B is H, then A plus B and A minus B are also divisible by H. If HCF of two numbers is 8, HCF of two numbers is can also divide individually the sum and the difference of two numbers. So this is another important thing. The next important thing is for fractions. So HCF of fractions is equal to HCF of numerator divided by LCM of denominators. Similarly, LCM of fraction is equal to LCM of numerators divided by HCF of denominators. Okay. For example, let's take one example. Let's say 1 by 2, 4 by 8, and let's say 16 by 20. These are 4 by, let's say 12. These are three fractions. What is the HCF? HCF is HCF of 1, 4, and 16 divided by LCM of 2, 12, and 20. So HCF of 1, 4, and 16 is 1. LCM of 2, 12, and 20, if you do it, 60. You can calculate that, it will be 60. So HCF of all the three fractions are this 1 by 60. Similarly, LCM if I do, it will be LCM of 1, 4, and 16 divided by HCF of 2, 12, and 20. Okay. LCM of 1, 4, 16 is 16. LCF of 2, 12, and 20 is 2. So LCM is 8. Okay. So these are, if this is the fraction, this is your HCF, this is your LCM. So that's how you do for fractions. So these are the very important understandings. Let's solve one or two problems before we get to the last phase of HCF LCM. Let's say, let's take this problem. Let's take three different type of problem. So let's say sum of two numbers is 40 and HCF is 5. N1, N2 is what? So how many pairs are possible and what are those pairs? Okay, let's take the second example of, let's say same sum of two number is 124, whereas the LCM is given as, let's say 93. Again, N1, N2, what are the values of N1, N2 they can take? Really, the third problem, say sum of two numbers. Let's say another problem, sum of two numbers, again same two numbers is 50, but here the HCF is given as 5 and LCM is given as 105. Again, you need to find out N1, N2 is how much. The same thing, where somewhere the sum HCF is given, somewhere the LCM is given. So let's say for the first problem, let's say the numbers are N1, N2, right? So I can say N1 plus N2 is 40 N1 plus N2 is 40. And we know N1 into N2, N1 into N2 is basically 5 into 5 is the sum. So 5 K1, K2. Okay. Also, since the HCF is your 5, we can actually write N1 is as 5K1, N2 is as 5K2, because that will be the common factor and K1, K2 will be two different one. And actually from here only you can write this. Okay. This is your HCF and the 5K1, K2 is your LCM. So I can write 5K1 plus 5K2 as 40, or from here I can write K1 plus K2 is 8. Now, if I know K1 plus K2 is 8, if I know my K1 plus K2 is 8, then how many values K1, K2 can take? Because I know K1, K2 has to be a co-prime. So we know K1 and K2 has to be co-prime. So if K1, K2 has to be co-prime, K1 can take 1 and K2 can take 7. Or how many ways you can write 8? 8 you can write as 1 plus 7, 2 plus 6, 3 plus 5, or 4 plus 4, right? 4 plus 4, this is not a co-prime. 2 plus 6 is also, these two numbers are not co-prime. So the only possibility is K1, 3, K2, 5. Okay. So the numbers possible is either 1, 7, 1 or 7, or 3 and 5. These are the two numbers possible. So your N1 can become either 1 and 7. So your N1 and N2 can take either 5 or 35. 5K1 and 5K2. When K1 is 1, 5K1 is 5. K2 is 7, 5K2 is 35. So the N1, N2 can either be 5, 35, or they can be 15, 25. How we got? If K1 is 3, your 5K1 is 15. If your K2 is 5, 5K2 is 25. So that's why you can say N1, N2 is 5, 35 or 15, 25. These are the two possibilities. Similarly, take the other example. Sum of two number is 124, LCM is 93. So again, sum of two numbers is 130, 124. They said LCM is 93. Okay. Now I can write N1 is equal to HK1, where H is the HCF. N2 is HK2, where H is again the HCF. Then I can say HK1, K2 is basically your LCM, which is equal to 93. So H into K1, K2 must be equal to 93. H into K1, K2 must be equal to 93. Now 93 can be written as a product of two numbers in how many ways? 1 into 93 and 3 into 31. These are the only two possibilities. Now 93 is not a prime number. 93 is not a prime number. So there is a possibility. There is a possibility that H and K1, K2 become 1 and 93 or 3 or 31. Okay. We also know your HK1 plus HK2 is 124. So we can say H into K1 plus K2 is 124. So let's say you have two equations now. HK1, K2 as 93. H into K1 plus K2 is 124. Okay. H K1 plus K2 is 124. Okay. Now think on this and tell me what values K1, K2 can take and H can take. Now in this case, typically what we got from here, H, K1, K2, 1 and 93. So there is a possibility from here, there is a possibility that H can take 1 on C, H, K1, K2. So there is a possibility that H can take 1 and K1, K2 can be 93, where K1 is 3 and K2 is 31. K1 is 3, K2 is 31. So in that case, K1, K2 93, K1 is 3 and K2 is 31. In that case, obviously, can I say this is then H K1 plus K2 will not be equal to 124. Then H K1 plus K2, if H is 1 and K1 is 3 and K2 is 31, this is not going to be equal to 124. So that's not possible. So this is not a valid scenario. Okay, H1, K1 3 and K2 31. So this is not a valid scenario. So what is a valid scenario? So I saw H1, K1 3, K2 31. So 1 3 31 is not a valid scenario, right? If I have, and think this very carefully, if I have H as 31, so then H equal to 1 is not possible. Is it possible? So H cannot be equal to 1, that we have seen earlier. Now, if we have H cannot be equal to 93 also. So H cannot be equal to 93, because if H equal to 93, then K1, K2 has to be 1 and 1 each. K1, K2 has to be 1 and 1 each. Now, in that case also, K1 plus K2 will be only be 2. So 93 into 1 plus 1 is also not equal to 124. So H cannot be equal to 93 also. Come to the second case. Can H be equal to 3? If H is equal to 3, H cannot be equal to 3, because if H is equal to 3, your K1 plus your K1, K2 has to be equal to 31. If H is equal to 3, then if H is equal to 3, H equal to 3, then your K1, K2 has to be equal to 31. If K1, K2 has to be equal to 31, one of them is 1, the other has to be 31. Okay. Now in that case, this will become 3 into 1 plus 31, or 32 into 3, that is also not equal to 124. So H cannot be 1, H cannot be 93, H cannot be 3. The only option left for H is 31. Let's see. If H is 31, your K1, K2 can be 3, which can be 3 into 1. In that case, you can see, you can replicate this. This is H is 31 into 1 plus 3, which is equal to 124. So the only possibility is this: H is 31 and K1, K2 is 3 into 1. So your N1 in this case will be 31 and 93, or it will be 93 and 31, whatever value you give to 3. So what we did, we finally break this and then create multiple scenarios and see which scenario satisfy all the condition, which scenario does not satisfy all the condition. So listen to this problem again. If you have any difficulty, please reach out. And the third problem that we give, sum of two numbers equal to 50. You know the HCF and LCM. Okay. Now you have to figure out the number. So this is kind of a homework. You try this at home. We know sum of two numbers is 50, HCF is 5, LCM is 105. So again, I will just give you a high level overview. Sum of two numbers. So let's say N1 is a its CF is given, so its CF is 5. So 5K1 N2 equal to 5K2. So they said N1 plus N2, which is 5 into K1 plus K2 is equal to 50, right? And they said, what is the LCM? LCM will be 5 K1 K2, which is given to you as 105. So from here you can calculate easily. K1 K2 is 21. K1 K2 is 21. Now take K1 K2 in such a way that it will satisfy this condition. So from here I can say K1 plus K2 is 10. So you know K1 K2 is 21 and you know K1 K2 is 10. Now do a marry between these two and find out the values of K1 K2. It should be simple. You can do it and then replace it back. Okay. Now there are, finally, before wrapping up, there are few models of LCM calculation. Note it down. So LCM. The first says if if a number when divide by PQR always gives the same remainder, always gives the same remainder, the lowest, smallest value of that number is equal to LCM of PQR plus the remainder. So let's say, for example, a number n when divided by say 2, 3, 5 always gives a remainder of 1. Always gives a remainder of 1. When n divided by 2, remainder of 1, n divided by 3, remainder of 1, n divided by 5, remainder of 1, then the smallest possible value of n, smallest n, is LCM of 2, 3, 5, 2, 3, 5 plus 1. This is 30 is the LCM plus 1. 31 is the smallest possible value. Okay. The next value of n will be 30 into 2 plus 1. The next one is 30 into 3 plus 1. So the smallest possible value of n is 2 LCM, and the generic value of n, will be LCM of PQR multiplied by n plus 1. So basically, you can multiply that LCM. So basically, the first number is 31. The next number will be the LCM away. So if you multiply the LCM with 2, you will get the second number. If you multiply LCM with 3, you will get the third number. But the idea here is you need to identify. So basically, when a number divides by a set of numbers and give the same remainder, then the smallest possible value of that number is LCM of those 3 divisor plus the common remainder. Okay, so this is one formula. Okay. The second formula, if a number when divided by PQR gives remainder of A, B, C respectively, such that P minus A is equal to Q minus B equal to R minus C, then the number is equal to N is equal to LCM of PQR, and this is equal to, let's say, Y, LCM PQR into K minus Y. So what does it mean? It means any number and you are getting the same remainder as the same difference. So let's say a number N gets divided by, let's say, again, say 3, 4, no, 5. Okay, N divide by 3, 4, 5 gives remainder of 1, 2, and 3. Gives remainder of 1, 2, and 3. Now your remainders are not same. But if you see the gap between 3 and 1, the gap between 4 and 2, and gap between 5 and 3, these are same. So the gap is 2. So then the remainder is LCM of 3, 4, 5 minus 2. So 3, 4, 5 LCM is 60. 60 minus 2, 58 is the number. So if you divide 58 by 3, if you divide 58 by 3, you will get it. Okay. If you divide 58 by 3, you will get 1 as a remainder. If you divide 58 by 4, you will get 2 as a remainder. If you divide 58 by 5, you will get 3 as a remainder. So that's the only possible. So this is the way. And why the K? The significance of K is this is the smallest possible value. When you multiply this with K as 1, if you multiply this with 2, you will get the next possible value. So the next possible value of N is 60 into 2 minus 2. After that, it will be 16 to 3 minus 2, and so on. These are very, very important two formulas of LCM, and there's a lot of problem that can come through this. So that's what we just want to cover. One case when the remainder is same after dividing with different numbers. The other case is remainder is not same, but whatever the remainder you get, it's the difference between the remainder and the divisor is same in all the cases. So how to find out? So this formula and this formula, both are very, very important. Okay. So that's about it. I hope this session was helpful. You kind of understood the different nuances of HCF LCM, and we'll see you next time in another topic of number system. Hope you are enjoying the number system topic. Any doubt, please feel free to drop a note in the comment or drop me an email. We'll be able to help you, and see you next time. Thank you. Bye.